Right, let us start. So, what was the last topic? Where did we stop? I think it was blocks connected with strings, right? If two or more blocks are connected with strings and they are pulled with certain force, what will be the acceleration of each block? What will be the tension in the string developed? If there are more than one string, tension in each string, we were doing such type of questions. Next, after that, a very important concept is pulley block systems. Pulley block systems, or we also call this as Atwood's machine. Atwood's machine. Okay, what is it? A simple Atwood's machine will be like this. This is a fixed rigid support to which, from which a pulley is suspended. Pulley is suspended. What is a pulley? I think you might have seen a pulley or used it sometime. We use it to draw water from a well. A rope is tied to a bucket is tied to a rope, and that rope is run over a pulley. And when you pull that rope, the pulley rotates, and it will be easier to draw the water, or it will be easier to lift the load. So pulleys are mostly used in lifting loads easily with less of effort. You can lift the loads, heavy loads, with the help of pulleys. Okay. So from such a pulley, we are running a string over the pulley, and to one end of the string, let us say we are tying a mass m1. Okay, and to the other end we are tying a mass m2, and both m1 and m2, let us say, they are released from rest. Okay. Now what happens? You call this system as Atwood's machine, a pulley over which a string is run, and the two ends of strings are attached to two bodies. Okay. What happens if m1 is equal to m2? If I leave the two blocks equal masses at rest, what happens? Nothing happens. They will be at rest. They will be stable. Okay. Or they will be in equilibrium. But let us say m1 is greater than m2.
Sir, the weight will totally fall on M1 and it will fall, sir.
Oh,
So M1 will go down.
oh. See, what happens here is m1 is a body block something of mass m1, and it is suspended in air. This pulley block, this entire system is suspended in air from some, let us say, ceiling, roof of the room. Okay. Then the weight of this block m1, how much? m1g will be acting vertically downward. Okay. And weight of this block m2g, it will also be acting vertically downward. m2g. As m1 is greater than m2, m1g is greater than m2g. m1g is greater than m2g. That means m1 will go down and m2 will go up, because string is there tying, and the string is inextensible and massless. So m1 comes down, m2 goes up. Okay. Now, how does m1 come down? What will be its motion, uniform or non-uniform? What will be motion of m2, uniform or non-uniform? We have to study all these things.
Uniform, sir.
See, before that, how can we describe a pulley? Pulley, how can we describe it? What is it? What does it do actually? Pulley, it is a mechanical device. It is a mechanical device which can change the direction of applied force. Pulley is a mechanical device which can change the direction of applied force. What does this mean? How can a pulley change the direction of applied force? Imagine a simple situation. This is a well, and you have to. You are given. Let us say you are standing here, and you are drawing. This is a okay. This is some rigid support. This is the pulley, and this is the rope. Okay, to which some vessel, let us say a bucket, is tied, and you are to lift water from the well. What do? You'll pull the rope. In which direction?
Downward, sir.
Downward.
You are pulling the rope down. That means the force applied by you on the rope is in downward direction. Okay. What happens to this bucket load?
It will come up, sir.
It moves up. If it is moving up, means some force must be acting on it. In which direction? Upward direction. What is that force?
Muscular.
Tension force. The tension developed in the rope is pulling the bucket up. But what was the direction of tension applied by you on the rope? Downward.
The downward.
Tension was developed in the rope in downward direction because of your pulling. But that tension is acting on the bucket in upward direction. How did this change?
Change in direction because of the pulley, sir.
Because of the pulley. Suppose if without a pulley, another fellow who is standing here, he wants to draw water without using a pulley. This is the rope. This tied to another bucket. Now, in which direction should this fellow apply force?
Sir, upward.
Upward direction. Then the bucket will also move upward. Force is upward. Motion of the body is also upward. Okay, no problem. But here force is downward, but motion of the body is upward. This direction is reversed. Direction of applied force is changed. Who is doing this? Pulley is doing this. Pulley is doing this. Or it can be also like this. Let us say this is a horizontal surface. This is a block of some mass m. It is tied to through a string, and this is running over a pulley. You are standing here and you are pulling the rope down. Force is applied in downward direction. But what is the direction of motion of this block? Towards right. Force is downward, but motion is towards right. Again, change. That means this force must be acting on the block in this direction. That means the direction of applied force is changing because of the pulley. So this is what a pulley does. It can change or it changes the direction of applied force. Okay. Now, come to this situation, this example, M1, M2 suspended. M1 and M2 suspended through a pulley. M1 is heavier than M2. So weight of M1 is more than weight of M2. That means M2 will go down. M1 will go down. M1 will go down. If M1 goes down, that means it is moving. We should understand how will it move, with constant velocity or with acceleration.
It depends on the force applied, sir.
We are not applying any force. We are just connecting two blocks of different masses and leaving them from rest at the same level. We are not pulling, we are not applying any external force. Because of their own weight, M1 will come down and M2 will go up. Up to this point, it is clear. But now, how will M1 come down? With constant velocity or with acceleration?
Sir, you can say
Acceleration, sir.
Acceleration, sir.
Acceleration. Because M1G, when weight of M1G acts down, that weight will be pulling M1 down. Because of that weight, tension will be developed. Tension will be developed in the string. In which direction? In this direction, upward direction. Okay. And we have already discussed tension in detail. This tension will be uniform, same throughout the length of the string. And one string, one tension. At any point of the string you take, the tension will be same in magnitude. But this tension which acts on M2, it will be in this direction. Same tension, T. And M2G is acting downward. Now if you take M1, block M1, two forces are acting on it. Its weight M1G downward, tension in the string T upward. If you take M2, two forces are acting on it. Its weight M2G downward, tension in the string T upward. So that means on two blocks, there will be a resultant force or a net force. If there is a net force, there will be acceleration. So these two blocks will move with accelerations. Is that acceleration equal to G? Is that acceleration equal to G?
sir. Yes, sir.
No, it's
Yes.
equal to G. G is acceleration of a body which is in free fall. If I leave this, if I cut this string, then M1 will be falling free. Then its acceleration will be equal to acceleration due to gravity. Here it is not in state of free fall. This tension, the string is tied to it, tension is pulling it up. So upward force is also acting on M1. Try to understand the difference between M1 released from rest, which is not tied to anything. M1 released from rest and M1 falling down. This M1 will fall down with acceleration which is equal to acceleration due to gravity, 9.8. But here this M1, it is not in free fall. It is not falling like a ball released or some stone released. It is tied to string. So the tension in the string is pulling it up. Gravity is pulling it down. Who wins? Gravity wins. That means, does this tension become zero? No, there will be net force. There will be net force. Because of that net force, M1G is coming down. And what about M2? Tension is pulling it up. M2G is pulling it down. But this is moving up. That means tension is more than its weight. Here, its weight is more than tension acting on it. Because of all these things, M1 comes down, M2 goes up. Now we have to find what will be the acceleration. Another one, if they are moving with accelerations, will they move with same accelerations or different accelerations? M1 comes down, M2 goes up with acceleration. Will this acceleration be same or will it be different? We studied strings, tension in string. This string is inextensible and massless. That means it cannot stretch, it cannot elongate. If it cannot
Equal
elongate,
acceleration, sir.
they should have same acceleration. If this comes down 1 meter, if this moves down with if m1 moves down with acceleration 1 meter per second square, m2 should move up with same acceleration 1 meter per second square. Because string does not stretch, then this should happen. Acceleration should be same, but opposite in directions. So accelerations of the two blocks will be same. And how much will be that acceleration? And what will be the tension in the string? This is what we should find out. Okay. So first, acceleration of the system. Acceleration of the system. As the string is massless and inextensible, the two blocks move with same acceleration. Okay. How much is that acceleration? Now, listen carefully here. In order to calculate the acceleration of pulley block systems, there are two methods which can be used. One method is drawing free body diagram of each block and writing the equation of its motion. If there are two blocks, you will get two equations of motion. And solving those two equations, we will get the value of acceleration. That is one method, general method, but a bit lengthy, time-consuming method. Another easy way to find acceleration of the block is by using the formula. Acceleration is net pulling force divided by total mass. This is a very important formula which you should remember. And this formula can be applied to any question of pulley block systems. Not only pulley block systems, wherever you need to find acceleration of a given system or bodies, connected bodies, like blocks in direct contact or blocks connected with strings moving horizontally, moving vertically, or blocks connected with strings run over pulleys, we apply this formula. Acceleration is net pulling force by total mass. This is not a new formula. It comes from the same old Newton's formula, Newton's second law, F equal to ma, from which A is F by m, force by mass. Acceleration is force by mass. If there are more than one force, you take the net force. If there are more than one masses, you take the total mass. It's the same thing here. Net force, I'm just calling it as net pulling force divided by total mass. Okay. Now, identifying the net pulling force in the given question is what you should understand now to solve questions. Identifying net pulling force is the key here. Okay. How to identify net pulling force?
Sir, what is Atwood's systems you wrote at the top right?
The name given to this is Atwood's machine.
Okay.
1 second. Oh, yes. Yeah. Net pulling force. Acceleration is net pulling force by total mass. So what is the net pulling force? See, this is just like what you call that. You play that game, no? Forgot its name. Two teams will be there, and one you take a
It's a tug of war.
tug of war game. So all questions related to pulley block systems are tug of war questions. This is the rope. If you apply the concept of tug of war, you can easily do all the questions. Team A, Team B. Team A is pulling towards this side by 100 Newton force. Team B is pulling by 100 Newton force. Which team will win?
The rope will breaks.
Nobody wins. If they keep on pulling with 100 Newton right side, 100 Newton left side, nobody wins. You tie something here, no kerchief or something, that will be at its in an original position only. If team A pulls with 200 Newton and team A is pulling with 200 Newton, what happens? The kerchief will move towards team A because this force is larger, this force is smaller. Resultant of these two will be 100 Newton towards right. So team A wins. Okay. Team B applies 200 Newton, team A applies 100 Newton.
So team B.
Team B will win because net force here is again 100 Newton towards left. Kerchief moves towards left. Okay. Both apply same force, nobody wins. The rope will win equally. The same thing happens in pulley block systems also. Same thing happens in pulley block systems also. You should identify what are the two forces. If two, or in some situations, it can be more than two forces also. When you study friction, you will understand. So you should first of all identify what are the forces that are trying to pull the system. Pull, or in general sense, move the system. System in the sense, this combination of two blocks. Okay, what are the forces? And remember, you should you should consider only external forces acting on the system. Only external forces. What is external force and what is internal force? External
The
force
external force through motion happens.
which acts from outside the system. Internal force is a force which is developed inside the system. Suppose you are going in a car, the car breaks down, and suppose you are sitting here in the back seat and you push your front seat. Will the car move? No, you are applying force here. Let us say you apply 100 Newton force on your front seat. Will the car move? No, because this is internal force. The force that you are applying is internal force. You are inside the car. You and car is a system now. You are trying to push the car from within the system. Internal force is developed. Internal force cannot cause motion. Internal force cannot cause motion. Okay. But if you get down from the car and push it, you apply the same 100 Newton force, you can see the car moves. What has happened here? Now your force applied here is external force. It becomes external force. So external force can cause motion. Only external forces can cause motion, not internal forces. So while writing net pulling force in acceleration formula, you should consider only, first of all, you should identify what are the forces acting on the system, and the two external forces, not internal forces. Now here, M1G, M2G, tension, tension. What are external forces and what are internal forces? What is our system first of all? Our system is this pulley, M1, M2 blocks, and the string. This is our system. Any force which acts from within the system is internal. Any force which acts from outside the system is external. So M1G, M2G are acting from outside the system. They are due to gravity outside the system. So these are external forces. Tension is developed within the system. So this is internal force. Tension is internal force. And tension cannot cause motion. Tension cannot cause acceleration in the blocks as a whole. Okay. Then in the formula net pulling force, I should take only M1G and M2G. Using M1G and M2G, what is the net force? Is it M1G plus M2G, M1G minus M2G, or M2G minus M1G? What is the net force? M1G, we started this with the condition M1 is greater than M2.
M1G minus M2G.
That means M1G is greater than M2G. That's why M1 comes down and M2 goes up. If M1 is coming down, that itself means M1G is greater than M2G. Tug of war. This is tug of war. Who is winning in this tug of war? M1 is winning. So net force will be M1G minus M2G divided by total mass M1 plus M2. M1 plus M2. So we can write the acceleration as M1 minus M2 by M1 plus M2 into G. This is the acceleration of the system or acceleration of each block. They will be same. So you get the acceleration by using what formula? Net pulling force by total mass formula. Okay. Next, we also need tensions in each tension in the string. Tension in the string. Tension in the string. How to find this? To find tension in string, we have to draw FBD, free body diagram of which block. You can take any block, M1 or M2. I will take M1. I will take M1. So this is M1 block. We should show all the forces acting on M1. What are the forces acting on M1? M1G, its weight downward. Tension T upward. Then is it stationary or is it moving? Moving. With acceleration. In which direction? Downward direction. So it is moving down with acceleration A. Some acceleration A. The value of which we have already got M1 minus M2 by M1 plus M2 into G. Okay. So M1G downward, T tension T upward, acceleration A downward. To this M1, to this block M1, if I apply Newton's second law, apply F net equal to MA. F net equal to MA. What is the net force here on M1? Whenever more than one force acts on the body, immediately you should go for net force to understand its motion.
Sir,
What?
M1G minus T.
M1G minus T or T minus M1G? Is it M1G minus T or T minus M1G? How to decide this? Tug of
Sir,
war.
M1G minus T, sir.
Again tug of war. How?
M1G is coming down means T is less, sir.
In which direction is M1 moving? Downward.
Downwards.
Down.
If it is moving downwards, definitely the force which is acting downward should be larger than the force acting upward. Tug of war.
M1 minus G, sir.
So net force will be M1 minus T. M1G minus T. Don't write M1 minus T. M1 is not force. M1 is only mass. So M1G minus T is the net force. In place of F net, I am getting M1G minus T. Okay. Equal to M mass. Which mass? M1. into A. Acceleration is this. So I can put all this value here. M1 into M1 minus M2 by M1 plus M2 into G. Now what to do? Simple. You open the brackets on right side, take out some common terms, and we want tension, right? We want tension. So we will put tension on one side. Okay, I'll rewrite this as T is equal to M1G minus M1 into M1 minus M2 by M1 plus M2 into G. Okay, right. M1G minus, open the brackets, you get M1 square minus M1 M2, or I'll take G also. M1 square G M1 square G minus M1 M2 G by M1 plus M2. Okay, LCM T is equal to M1 G into M1 plus M2 minus M1 square G plus M1 M2 G by M1 plus M. Okay, again open the brackets. Again open the brackets. M1 square G plus M1 M2 G minus M1 square G plus M1 M2 G divided by M1 plus M2. M1 square
Sir,
G.
M1 into M2G, sir. You wrote M2 into M2G.
Oh. So M1 M2G, M1 M2G. 2 M1 M2 by M1 plus M2 into G. This is the tension. 2 M1 M2 by M1 plus M2 into G. This is the tension. And what is the acceleration? We already got it. M1 minus M2 by M1 plus M2 into G. Acceleration is M1 minus M2 by M1 plus M2
G.
into G. These are the acceleration of the system and tension in the string. Tension in the string. Okay. You need not remember these formulas. Not necessary to remember these formulas. You should understand what we are doing here. Application of the concept is important. What formulas are we using here? Only one simple formula, F equal to ma. This is the only formula that we will use to solve any question on fully block systems. You can get 1,000 different types of questions, but formula is only one, F equal to ma. F equal to ma. Or from that you get acceleration equal to net pulling force by total mass. Okay. So to find acceleration of the system, write net pulling force by total mass. Then to find tension in the string, take the free body diagram of any one body on which the tension is acting. Right, draw the free body diagram, show all the forces, apply F net equal to ma to that situation. You will get the tension. This is the general method. Okay. Now, how can we, suppose you get a question like this. If instead of this general values, if I give you some numerical values.
Sir,
Uh,
sir, that means once can you show the formula for tension?
so if I
Sir.
Give a system like this. This is a pulley block system. This is a 2 kg block. And this is a 4 kg block. If the system is released from rest, then find acceleration of each block and tension in the string. This is the question. If the system is released from rest. Okay, how to do this? See, simple. Forget that formula, all those things. Remember only F net equal to ma, or acceleration equal to net pulling force by total mass. Okay, first of all, acceleration. Net pulling force by total mass. What is the net pulling force? I didn't show the forces here. If 4 kg block mass is 4 kg, then this is 4g acting down. This is 2g acting down. Tension in the string upward here, tension in the string upward here. Okay, net pulling force is 4g minus 2g. 4g minus 2g net pulling force divided by 4 plus 2. 4g is 40 if you take g10. 2g is 20 by 6. 20 by 6
10 by
meter per second square is the acceleration of each block. Okay, in which direction? This comes down, this goes up. Okay, fine. Now what about tension in the string?
Sir, we can simplify that, sir. 20 by 6.
You can do that. Tension in the string. Tension in the string. To find tension in the string, you take the block in which you on which this tension is acting. Draw its free body diagram. This time I will take 2 kg. 2 kg block. On 2 kg block, tension is acting in upward direction. Its weight 2g is acting in downward direction, and its acceleration is upward. So, if I apply F net equal to ma,
80 by 3.
F net equal to ma, net force on 2 kg is T minus 2g, because it is moving up. Upward force will be larger. T minus 2g is equal to mass. Mass is 2. Acceleration A. Acceleration is, we have got it, 20 by 6. 20 by 6. Okay. T minus 2g is 20. 2 into 10, 20 is equal to 40 by 6. That means T is equal to 20 plus 40 by 6. T is equal to 120 plus 40.
160 by 6.
160 by 6 is the tension. That's all. So this is one simple question. We can get different situations. We'll discuss them tomorrow.
Sir,
Hmm.
just if we don't know the acceleration, we should use the other formula, right? And when
Which
we know the
formula?
acceleration, we should use this formula.
Which formula?
So that M1 to M1 and to 1.
I told you to not remember that formula. That formula is applicable to only that situation, only when the blocks are given like this. If you remember that formula, you can do questions only like similar to this question. If the arrangement is slightly changed, that formula will not work. So don't remember that formula. It's useless. Remember the procedure, remember the concept. Okay, we'll continue some more questions tomorrow.